Hello, I'm Patty Simpson with Simpson Math. Let's multiply some polynomials. Now, we've looked before at the distributive property, and really that's all we're going to do here, is use that distributive property to help us to multiply. We know that we can multiply this 3x squared by this quantity of 5x minus 2 by using that distributive property. We can distribute the 3x squared to the 5x and the 3x squared to the 2. When we do that, we're just going to multiply 3x squared times this 5x, and then we're going to multiply that 3x squared by this negative 2. 3x squared by the 2. Now, when we multiply these, we multiply the coefficients. 3 times 5 is 15. And then remember from the exponents, our product rule in exponents, we have 2 x's here plus another 1 there, makes a total of 3 x's, or x cubed. So x squared times x gives us x cubed. Now we're going to multiply our coefficients here. A negative 3 times 2 gives me a negative 6. And then that x squared doesn't have anything to multiply by, so it's just x squared. Now I can't combine these two terms because they're not like terms. X cubed is a different number from x squared. So I have 15 of this number minus 6 of that number. I can't combine those. I have to stop there. I've simplified this as far as I can. We're going to simplify this one as well. And again, all we're going to do is multiply and distribute that 4x cubed to the terms inside the parentheses there. So we're going to multiply this 4x cubed times the negative 2x squared. And then we're going to multiply that 4x cubed times the 3x. We multiply the coefficients, so 4 times a negative 2 gives me a negative 8. And now 3x is multiplying together times another 2x, x is multiplying together, gives me a total of 5x's multiplying together, or x to the 5th. Then I multiply these coefficients together. 4 times 3 is 12. And then here I have 3 x's multiplying together plus another 1x, or times another 1x multiplying together. So I have 4 x's. Or we can use that product rule where we add our exponents together. Again, we cannot combine these because they're not like terms. We have a negative 8 of these x's and 12 of those x's, of those numbers, but I can't combine them because they're not the same number. X to the 5th is a different number than x to the 4th. We're going to distribute this negative 2x times y squared. This time though, I have 3 terms inside these parentheses that I'm going to multiply that by. Let's see if we can do it without writing it out for each one. So I'm going to multiply this negative 2x y squared times this x squared. Ignore those other two for a minute. I multiply the coefficients together, so negative 2 times 1 is just negative 2. This x times that x squared, that gives me x times x times x, which is x cubed. And then the y squared times 1 is just y squared. Now, I'm going to multiply this coefficient by this coefficient. So negative 2 times negative 2 makes that a positive 4. This x times that x is x squared. And y squared times y makes that y cubed. Then here I'm going to multiply their coefficients. Negative 2 times negative 3 makes that a positive 6. X doesn't have anybody to multiply by, or doesn't have any other x's. and then y times y times y times y gives me y to the 4th. So for each one of those terms, there were 3 terms inside the parentheses. I'm multiplying this term by each one. I end up with 3 terms when I'm done in my product as well. Maybe I write this to help me see it. I could write it like this: x squared minus 2x plus 6 times negative 2xy. You could think of it this way, where I'm multiplying this times that. So negative 2 times 6 gives me a negative 12xy. I'm going to multiply this times that. Negative 2 times negative 2 is a positive 4. X times x is x squared. And then the y, they're all multiplying together. And then last but not least, when we multiply negative 2 out front, x times x times x is x cubed. And then there's that y. Again, I had 3 terms inside my parentheses. This negative 2xy, I just distributed to all 3 of those terms. So I had 3 terms in my product as well. So when I'm distributing and I have a number on the outside of the parentheses, I can distribute it to the numbers inside, to the terms inside there. Now, we've used the distributive property where we have one term on the outside of the parentheses that we are distributing to terms on the inside. We're going to make it a little more challenging and a little more difficult here. So before we do that, I want to just show you how the distributive property works when we're dealing with 2-digit numbers, or if we were dealing with 3-digit numbers, how this distributive property can work for it as well. So I know here in America we have an algorithm for multiplying where we would just do this. We'd say 5 times 2 is 10, and then we'd carry our 1. And then we'd say 5 times 1 is 5, plus that 1 makes 6. Then this number right here in America, a lot of times we say it's a 1, but it's not really a 1, it's a 10. And because it's a 10, we put down this 0 for that placeholder, because when we multiply by 10, it's going to end up with a 0 there. Then we say 1 times 2, or 10 times 2 gives us that 20. 1 times 2 is 2. And then 1 times 1 is 1. So if we multiply 10 times 1 by times 12, we get 120. Then we add those two together so that we get 0, 8, 1. That's one algorithm for multiplying those 2-digit numbers. Another way we could do this, though, is we could take these numbers and we could expand them. We could write them in expanded form as 10 plus 2 and as 10 plus 5. And then we could do something very similar to what we just did, where we take the 5 and we multiply it times both of those terms. But notice that we haven't added these together yet. We're going to wait till the end to add them together. So I'm going to multiply this 5 times the 2, excuse me, and get the 10. And then I'm going to multiply the 5 times the 10 and get 50. It's similar to what we did over here, 5 times 2 and 5 times 10. I'm just writing it out here before I add these. I'm going to add at the end. Now I'm going to multiply this 10 times the 2 to get 20, and 10 times 10 to get 100. So notice that this 5 multiplied times both of the terms, or both of the numbers, and the 10 multiplied times both of the places as well. Now I'm going to add that all together. At the end, I'm going to add them. So 1 plus 5 is 6, plus 2 is 8, and then 1. Notice I got the same answer both ways. I could turn this, if I turned it and wrote it out this way, I could use this same idea. Let me put the 15 in front instead, just to show that what I did was I took this 10 and I multiplied times both of the numbers. So I'm going to show that here. I'm going to multiply this 10 times both of the numbers. I did that here. I did this 10 times both of those numbers. Here they are. 10 times both of the numbers. I'm going to get that same thing here. 10 times 10 is 100. 10 times 2 is 20. Then also I multiplied this 5 times both the numbers. I'm going to do that as well. 5 times both of the numbers. I'm going to distribute it to both of those numbers so that I end up with 50 and 10. Same numbers I ended up with over there. When I add all that together, I get 180. Now, this is another way that we can do the problem. And this really shows this distributive property that we're going to be using. Sometimes when we're dealing with polynomials, we cannot combine the terms because they are not like terms. And so we have to use this distributive property to help us to multiply. Now, some of you may have learned an acronym to help you with this multiplication called FOIL. FOIL is only an acronym that we can use when you have a 2 by 2. If you have more numbers than that, then FOIL falls us down. So it's better just to understand that what you're doing is you're distributing this 10 to every term over with the next number. And then in the ones place, I'm distributing that number to both places in the other number. But if you know FOIL, if you've learned that in the past, what it stands for is first. So we multiply the first numbers together first. The outside, so outside. So I'm multiplying the outside to get numbers together next. The I stands for inside. So I multiply the inside numbers together next. And then the L stands for last, because I'm going to multiply those last numbers together last. And then once I've multiplied my first numbers, my outside numbers, my inside numbers, and my last numbers, I add it together. So you may know this acronym. It's kind of what if you're familiar with that, then what you're doing is the distributive property, and we're going to practice using that distributive property. Okay, we're going to practice using that distributive property. Here I have a binomial, that means it has two terms there, times a binomial. We're going to multiply these two together. And we could write it like this, if it helps us, with one on top and one on bottom, just like we would if we were doing 12 times 15. And then we could multiply 1 times 2 and 1 times x, and then multiply 3x times 2, and multiply 3x times x. 3 times 1 is 3, and x times x, there's 2 of them, so it's x squared. And then I can only combine my like terms. So I can only combine these guys. I'm going to add them together, but those are the only ones I can combine. So I have 3x squared plus, well, 6 plus 1 makes 7x plus 2. Most of the time, though, when we do this, we're just going to look at it and we're going to distribute each of our values times one another. So x times 3x gives me that 3x squared that we see out front here. This x now needs to multiply times the 1 so that we get x times 1, which is x. We see that x value here. Now, the x has distributed to both of those terms. Now I'm going to distribute the 2 to both terms. So that I have 2 times 3x, which gives me 6x. We see that 6x here. and 2 times 1, which gives me 2, which again, we see that term here. Then I just combine my like terms. Typically, those like terms will be right here in the middle. If we can have anything to combine, they'll be right there in the middle. So that we end up with a trinomial of 3x squared plus 7x plus 2. Notice that was the same as this. Let's practice distributing it here. Let's start with this 3a. It's going to distribute to both of these terms inside of that set of parentheses. When we multiply the coefficient times the coefficient. So 3 times 4 is 12. And then we multiply the variables together. So a times a is a squared. Now I'm going to multiply the 3a times the negative b. Well, 3 times negative 1 gives me a negative 3. The a and the b, I'm just multiplying times the a and multiplying times that b. I've now distributed the 3. Now I'm going to distribute this negative 2. So I have negative 2b times 4a. Well, negative 2 times a positive 4 makes a negative 8. Sorry, it's a negative 8. And then the a and the b are multiplying together. Notice that these two are like terms. They have the same variables, so we will be able to combine them. Then a negative 2 times a negative 1 makes that a positive 2. And then the b times a b is b squared. I can now combine my like terms. So I have 12a squared, negative 3 and negative 8 makes that a negative 11, ab, and then the plus 2b squared. I cannot combine anything else. A squared is not the same as ab, is not the same as b squared. These are not like terms. That's as far as I can go. I've simplified that, or I've multiplied those binomials. Notice that this one says 7x minus 2y squared. Remember what that exponent of 2 means. It means that I am taking this binomial and I am multiplying it by itself. I cannot just distribute that 2 to both terms. I have to multiply everything inside this parentheses by itself. When I do that, I need to use that distributive property. So first I'm going to distribute this 7x to both terms inside the parentheses. So that I have 7 times 7 is 49, and x times x is x squared. Then I'm going to multiply the 7x times the negative 2y. So 7 times negative 2 gives me a negative 14. And then the x times the y, they're multiplying together. I've distributed that 7x to both terms. I'm now going to distribute the negative 2y to both terms. So this negative 2y, I'm going to multiply times the 7x. So negative 2 times 7 gives me a negative 14. And then the x and the y are multiplying together. I could write it as yx because multiplication is commutative. But since I wrote this one as xy, I'm going to write that one as xy also. Then I'm going to multiply the negative 2 times the negative 2, which gives me a positive 4. And then y times y is y squared. Again, these middle terms are the ones where I can combine. I can combine those two xy's. This is like that. So I have a negative 14 and a negative 14. I walk into negative land. I keep walking into negative land. I ended up with a negative 28xy. Remember, when I'm multiplying, x times x gives me x squared. But when I'm adding or subtracting, I'm just looking at negative 14 of these and negative 14 of these. So I end up with a negative 28 of those numbers. And I've simplified this binomial squared. Be sure anytime you have a binomial squared to write it out as a binomial times a binomial to help you. You should end up with a trinomial. Every single time you have a binomial squared, you will end up with 3 different terms, a trinomial. One last practice, and then we'll make it a little harder. We're going to first distribute that 7x to both terms so that I have 7x times 7x, which is 49x squared. By the way, this problem is very similar to that one. But in this one, it has a minus in both of them. This is the same as that. I cannot write this one as 7x plus 2 squared because these two are not exactly the same. In order for it to be squared, they have to be the same multiplying by themselves. These are 2 different numbers. So I've multiplied the 7 times the 7x times 7x to get 49x squared. I'm going to multiply the 7x times the negative 2, and I get negative 14x. Now I'm going to multiply the 2 times the 7x to get a positive 14x. And then last, I'm going to distribute that positive 2 to the negative 2. So positive 2 times negative 2 makes it negative 4. Again, I combine like terms. The only ones I can combine are this negative 14x and positive 14x. Now this time I walk into negative land, but then I turn around to walk back to positive land. And since I walk the same distance, that becomes 0. I'm just left with 49x squared minus 4. Notice in all the others, when I multiplied a binomial times a binomial, I ended up with 3 terms. A trinomial, 1, 2, 3 terms. Here I multiplied 2 terms by 2 terms, and then I ended up with 3 terms. Same thing here, I multiplied 2 terms times 2 terms and got 3 terms. The only time I'm going to end up with only 2 terms is if inside they look exactly the same, but one of them is a positive and the other is a negative. Because when that happens, these 2 middle terms will be the same, but with different signs. And so it'll make them add to 0. So the only time you should end up with 2 terms after multiplying a binomial times a binomial is if they're identical except for the sign in the middle. We're going to continue to use the distributive property with some more and more difficult polynomials that we're multiplying together. So before we multiplied a binomial times a binomial, in this one I'm going to multiply a binomial times a trinomial. For those of you who are using the acronym FOIL, this is going to fall down on you using that because FOIL is only meant for a binomial times a binomial. So here it's really important that we're just able to use that distributive property, that we recognize what we are doing is distributing this x to each of the terms in our polynomial that we're multiplying by. So I'm going to take this x and multiply it times each one of these terms. There's 1, 2, 3 terms in this polynomial. 1, 2, 3 terms. So I'm going to multiply that x by all 3 of those terms. The coefficient in front here is 1, so 1 times 2 is just 2. And then I'm multiplying x times x times x, which is x cubed. Now I'm going to multiply this x times that x, which gives me x times x, which is x squared. And now I'm going to multiply the x all the way over to the negative 6. So I get negative 6x. Now I multiplied that x times all three of my terms. Now I'm going to multiply the 1 times all three of the terms. I'm going to distribute that 1. So I have 1 times 2x squared. Well, 1 times anything is just itself. So 1 times 2x squared is just going to be 2x squared. Now I'm going to distribute the 1 to the x. So 1 times x is just x. And then the 1 times the negative 6 is just negative 6. We're going to combine our like terms. Some people like to take this and line it up underneath. So you might write it like this instead. You might say this one has an x squared, so I'm going to put it with that x squared. This one just has an x, so I'm going to put it with that x. And then we have the minus 6 out there. So maybe as you multiply, you line it up with some terms that are alike. Or you can just combine them as you see them. The x cubed, though, doesn't have anybody to add to. He doesn't have a like term to add to. Here I have 2 of these guys. I'm adding to 1 of those. And I'm adding, so I'm not multiplying. So it's not x times x times x times x. So I'm not going to end up with x to the 4th. I'm adding. I have 1 of them. I'm adding 2 of them. I end up with 3 of these guys, of these x squareds. Same thing's happening here. I'm adding them, a negative 6 of them plus 1 of them makes a negative 5 of the x's. Again, I'm not multiplying, so it doesn't become x squared. And then that negative 6 is on the end. So when I multiplied a binomial times a trinomial, I ended up with 4 terms here. 1, 2, 3, 4. And notice we didn't just have first times outside times inside times last. We had more than that. We had to do 6 different multiplication there in order to distribute those. So you just think of it as the distributive property where we're distributing our term to each one. Here I have a binomial times a 4 term. So again, FOIL would not work for me here. I've got to distribute this 3x to all 4 of the terms. So let's do that. 3x times x cubed. Well, the 3 times the 1 gives me 3. X times x times x times x is x to the 4th. So when I'm multiplying is when I add those exponents. Now this 3x has got to multiply times the x squared. So 3 times 1 is still 3. X times x times x is x cubed. This 3x is going to multiply times the negative 4x. Well, 3 times negative 4 is negative 12. And x times x is x squared. And one last term for the 3x to distribute to. So 3x times negative 2, 3 times negative 2 is negative 6 with that x. Now we're going to distribute the negative 1. Negative 1 times x cubed, well, negative 1 times 1 is a negative 1, and then I'm going to have an x cubed. That x cubed matches with this x cubed, so maybe I should put that negative 1x cubed here with that, so I know in a minute when I combine them that those are the 2 I'm combining. And then here I have a negative 1 times x squared, so negative 1 x squared, and again I'm going to end up combining these 2 because they're like terms. Then negative 1 times negative 4, well, a negative times a negative is going to make that a positive. 1 times 4 is 4, and then it has this x, so those are like terms for me to combine. And then last but not least, I have a negative 1 times negative 2. Negative times negative makes that a positive. 1 times 2 is 2. Now I can combine my like terms. The 3x to the 4th doesn't have anyone to add to. I'm adding here, not multiplying. So because I'm adding, I have 3 of them minus 1 of them leaves me with 2 of these x cubes. When I'm adding and subtracting, the exponent does not change. It's only when I'm multiplying that the exponent changes. Here I walk into negative land, I keep walking into negative land, so I end up at a negative 13. The exponent doesn't change when I'm adding and subtracting. I walk into negative land, turn around and walk back towards positive land, but I don't make it. So I'm at negative 2, and again the exponent doesn't change. So when I multiplied this binomial times that 4-term polynomial, I ended up with 1, 2, 3, 4, 5 terms there in my answer. And that's as simplified as I can get it. We're going to use that distributive property to help us simplify some polynomials. So here I have a number that's being multiplied by another number. And then we're subtracting a number being multiplied by a number. So I'm going to start by doing that multiplication. So I'm going to multiply this negative 7x, and I have to distribute it to each term inside my parentheses. So negative 7 times 1 leaves me a negative 7. X times x times x is x cubed. Now I'm going to distribute that negative 7 to the negative 2x. And a negative times a negative is going to make that a positive. 7 times 2 is 14. X times x is x squared. Now I'm going to distribute this negative 7x to 1. And negative 7x times 1 is just negative 7x. Now, there's another bit of multiplication going on here. Here I've got negative 3 multiplying times this trinomial. So I'm going to distribute that negative 3 to all 3 of those terms. Negative 3 times x squared gives me negative 3x squared. Negative 3 times x is a negative 3x. And then negative 3 times negative 3, well, a negative times a negative makes that a positive, and 3 times 3 is 9. Now I'm going to combine all my terms that are alike. I don't see any other x cubes, so that guy just stays a negative 7x cubed. But here I have a 14x squared, and there I have a negative 3x squared. I can combine those two. 14 minus 3 is 11, a positive 11 of those x squareds. Remember, when we add and subtract, we don't change the exponent. It's only when we multiply. Then I have negative 7x's minus 3x's. So I can combine these two because they are also like terms. So negative 7x minus 3x is a negative, walked into negative land, kept walking into negative land, a negative 10x. And then this 9 doesn't have anything that's like it to combine with. Here I have simplified that. I can't combine any further, so that's as far as we can go. I'm now going to simplify this one. Same idea as there. But here, the number that's out front that needs to be multiplied is 1, and the number out front here is a negative 1. If I distribute that 1 times anything, it just leaves me with that 5x squared minus 3x minus 5. But here, you can picture a 1 being out there so that you have a negative 1 to distribute to all 3 of those terms. Well, a negative 1 times a negative x squared, a negative times a negative, makes that a positive x squared. Here I have a negative 1 times a negative 4. Well, a negative times a negative makes that a positive 4x. And then a negative times that positive 9 is going to make that a negative 9. So we distribute it to all three of those terms. Now we're going to combine any terms that we have that are alike. So here I have an x squared, and there I have an x squared. So I can add those together. 5x squared plus 1x squared gives me 6x squared. I can combine my x terms. So I have a negative 3x plus 4x. Well, 4 minus 3 is just 1, so that leaves me with just 1x. And then I have a negative 5 and a negative 9, which makes negative 14. So I have simplified these polynomials. I took care of the multiplication that was involved there. Big takeaways from this: when you have multiplication, one number where you're multiplying times a polynomial, be sure to distribute that number to all the terms. Then when you're multiplying variables, you add those exponents. But when you're adding the variables, the exponents do not change. So there's some work with some polynomials. Math Made Simple, it's some math. Thanks for watching.